All right. So welcome to the STL Angular Meetup. Tonight we've got Jack, who's going to be teaching us a little bit about testing. And before we get started with that, though, we'll run through another session of Angular FAQ. So last month we talked about observables and when to subscribe. And this one we've got a little bit easier topic here. Today we're going to talk about a frequently asked question of when do I use a constructor versus when do I use ng on init. So pretty common question. You find it quite a bit online. We hear it a lot in our classes. And so I'm just going to pull up a simple little Angular app, and we're just going to take a look at both of those constructs, see what they are, and see why you might use them. So right now on the screen, I've got just a basic Angular CLI application. It's up and running, and I haven't made any changes. In fact, if you go and look at the running output of it, it's just your standard Angular application. So ng on init, that is actually a construct that you find inside of Angular components. So if I pop into an Angular component, the app component here is really simple, and there's actually not much to it visually. In fact, we don't even see an ng on init. But if I were to start up my CLI and say I want to generate out a component, and we're going to call it just the hello world component. If I spin that up, you'll see that by default, Angular will actually add this implements on init to your components that they generate. You also see on line 12 that there's this ng on init method that's been added to your class. So what are these? What are they for? Well, to start, I'm just going to come in here and I'm going to start with a basic console log. And we're going to take a look at when these We're going to take a look at when these are actually executed. All right, so now if I save this, my app will reload, my console will come up. Actually, no, it won't. Because right now I've defined the component, but I haven't actually added it to my application. So let's go ahead and do that now. So we're going to go back to our app component, and I'm going to go ahead and just get rid of all that boilerplate they stuck in there. And I'm just going to add an app hello world component to my app component HTML, and this will now bring in that component. So now that I'm referencing it, not only do we see it on the screen now, but in our constructor, or in our console, we can also see hello from constructor and hello from ng on init. Okay, so we can see here that at the very least we know that the constructor actually is called before ng on init during the application starting up. And in particular, this construct right here, ng on init, is called an Angular Lifecycle hook. There's a whole collection of them. Most people at least are aware of it being a lifecycle hook, but it comes down to which one do I use when. Because as it stands, they both seem to indicate that, hey, this is a place where I can do things at the start of my application. So what's the difference? Well, obviously we find out that constructor is actually fired first, and ng on init is fired second. So you might intuitively want to think that, oh, ng on init, that's the first thing that's happened. Well, not really. What's going on behind the scenes here is Angular is creating a new instance of our hello world component, and the second it does that, the constructor fires and brings this component to life per se. But it isn't until Angular is able to actually take that class instance and attach it to the rest of Angular's lifecycle that it's able to say, this has now gone from an instance of a class to I am now a full-blown true blue component. Once that happens, that's when Angular says, okay, it's now time to inform the user of this component, the author of this component, that I have created this component, hooked it up to Angular, and all of the wiring is now complete. That's when it calls ng on init. So let's take a look at one of the most important differences between these two. So to do that, we need to break into the @input feature of Angular. If you're not familiar with that, this is what allows us to pass data into a component from its parent. So we're going to make a message input. This is going to be a simple string, and I'm going to initialize it to an empty string. Because I'm initializing it, I don't need the type there, so I'm going to say we're going to have an input called message, starts off as an empty string, and then I can say hello, and then bind in the message. If I just save that and run it, we'll see that all it says is hello. So going back to the code, next thing we want to do is we want to be able to set that value from the parent. Now to do that, we come back to our app component where we use app hello world, and we bind to the message property, and now we set some sort of value. Okay, let's see. Because this is an Angular binding, and I'm wanting to pass in text, I need to do one of two things. I either need to put it in quotes or remove the square braces. For now, I'm just putting it in quotes. So saving that, running back to the application, we see hello from the parent. So let's get back to ng on init. So if we were to come in here and add an additional console log parameter of the actual message that we have, we'll see our first important difference between the two. So here I've just said, right after you log those two statements, also include whatever the message currently is. All right, going back, bringing up our console, we see hello from the constructor, and there's no message, followed by hello from ng on init, and we actually see that from the parent. So what we're identifying here is that as part of that lifecycle I was describing, where Angular says, not only have I created this instance, but I've also gone ahead and wired up all the wiring. Because of that fact, ng on init doesn't fire until after the inputs and outputs from the parent to the component in question have actually been wired up and the initial value has been fed in. So this is really important difference here, because if you actually have code that depends upon that input value at the start of your component's lifecycle, then ng on init is the earliest you can gain access to that value. Constructor is no good for you there. So we still haven't answered the question of, so which should I use? Well, a lot of people see this and they say, well, to be safe, I'm just always going to use ng on init. And a lot of other folks say, you know what, because you're already kind of in this world of Angular, you should be using Angular facets and features fully, and you should always put all your initialization code in ng on init. However, I actually think that there's benefit in using both of these in concert. In my opinion, if you have code that needs to run at the start of your component's life that does not depend upon your inputs and outputs, if you place that code in your constructor, that sends some intentional signaling to the future developer that works on your code to say, you know what, this code actually is free of any dependency on any inputs or outputs. Inversely, if I were to only ever use ng on init for code that has a dependency on an input or output, future developers never need to look at that and wonder, hey, why is that in ng on init? Is there an actual reason? Is there a timing issue if I were to move that code somewhere else? So, in my opinion, there's value in separating them, using them both in concert, just depending upon what your needs are. So, one last thing I want to show is that whenever you have, let's see, what's the actual thing here? ng change it? Help me out here. What's the type definition for this? Simple changes? Nope, that wasn't it. Right. Sorry, scratch that. So extending this idea, this is great for that first value, and a lot of folks say, well, what if I need subsequent updates, right? What if I need more than one once? And what if I need to be notified every time a value changes? There's a bunch of different methods for that, but that is when you roll into ng on changes. In ng on changes, it actually fires anytime any of the values of your inputs change. Now, again, similar question. So should I use ng on init, on ng changes on change, sorry. Or should I be just sticking to the constructor? Again, that depends on what you're trying to achieve and how intentional you want to be about the signal of what kind of code lives in each of these blocks. So that is the answer to what's the difference between the constructor and on init and when you'd use them. So up next, Jack's going to take us away here. Oh, question, yes.
There's only one other comment that I want to make up here. I will readily admit I used to be in that camp of everything works in ng on init, some things work in the constructor, so I'm just going to always use ng on init. When I started writing TypeScript code for Angular in strict mode, which includes strict property initialization, strict property initialization says that if you define something like message, it has to be given a value. You can't just like leave it undefined or null, or it has to be marked as optional. There are two places that you can give that value, either at the point of definition or inside the constructor. You can't initialize it inside of ng on init and make strict property initialization happen. So the constructor is really your only choice if you don't give it the value at the point of definition.
Right, so for the folks online real quick, what the point Bill was getting at here was that if we go back and we have in our application a situation where we are using strict null checks, there's only a couple places where you can kind of get around this need to declare that something might possibly undefined, and that is either at the point of initialization like we have on line 2. So at line 2 I could say, yes, this is a string, here's its initial value, and that will pass my strict null checks, or I can do that within the constructor. So let's say if I had dependency injection going on here and I needed some value from a service to initialize it, I could do that right here as well. And that will then pass your strict null checks. Strict property checks. And then that will, you cannot do that in ng on init because TypeScript's unaware of the fact that that's a runtime Angular construct that's called, not part of your component's actual class instantiation.
I feel like Jack is about to tell me more.
No, I was just going to add another thing on here. So under the hood, if you do an assignment at the point of definition, so under the hood, if you do an assignment like you've got on line 9, that actually compiles to in the constructor. So really, those are the same place. So it's not two different places that you can define it. It's really just one.
Yep. All right. Any other questions, comments? If not, I'm going to turn it over to Jack. So we're going to pause to get him mic'd up and get him plugged in, and then we'll get rolling with his presentation.
So hello everybody, as Paul said, my name is Jack Balbes, and today I'm going to be talking about embracing laziness in testing. So I want to start off by clarifying a little bit. Laziness in testing, there's a couple of terms that we need to talk about here. So laziness, by that I'm referring to one of the three virtues of the programmer, which is the idea that laziness is the quality that makes you go to great effort in order to reduce overall energy expenditure. So the idea here is that we're looking for places where we can do just a little bit more work in order to avoid a whole lot more work. And then the other part of this is in the actual testing, right? So when we're doing an Angular application, there are generally two different layers of testing that we create. There's unit testing, which we do with Karma and Jasmine, and then there's protractor end-to-end testing, which we do with Protractor and Jasmine as well. And I'm primarily going to be focusing on optimizing what unit tests we are looking to be writing in our Angular applications, but I'm going to be doing it informed by the end-to-end tests that I have available. So a lot of the optimizations that I'm going to be going through and saying, hey, we don't actually need to test this, I'm saying that, you know, knowing kind of in the back of my mind that a lot of the things that are in this code are actually being exercised by my end-to-end tests. So to kind of demonstrate this, I've just implemented, kind of similar to what you saw in Paul's example, I started off with a very basic Angular CLI application. I added just enough features to get some testing going. So if I zoom in here and come down here, so I have just 2 inputs that I can make changes to, and I can say something like, oop, changed, right? So I can make changes to it. It's going to go back, update a server that I have running in the background that's just a simple CRUD server. If I refresh the page, the data comes back when I reload. And so I'm going to go ahead and show the testing that I have in place here for this. So the first thing I'm going to do is show the end-to-end tests. So if I do npm run e2e, we'll see it's going to bring up my application. It's going to run through all, I need to kill it over here. Yes, there we go. So it's going to bring up my application. It's going to put it through its paces, and then it's going to go ahead and close down. And the idea here is that I've written this end-to-end test to exercise the user story for this feature that I'm testing, right? So, what did it? Why is it trying to connect to the internet? Is it trying to update? Do we have Wi-Fi, right? Which one? I
STL, all caps, OVE, all lowercase,
Okay.
T-Rex, all capital.
There we go. All right, 3rd time's the charm, right? There we go. So it's going to go through, it's going to put in some random data, and then it's going to check and make sure that that data survives the refresh, and then it closes down. So I now have an understanding, as I'm looking at my unit tests, that my end-to-end tests are actually fully exercising the feature that I want to deliver to the user. And so really, I'm not looking for trying to make sure that I put things together properly. Mostly I'm looking to make sure that my math is right? So something that the user might not necessarily notice when they're interacting with the application, right? If some value comes back wrong when I'm calculating it, the user is just going to keep using the application, and they're not going to necessarily notice that. So with that in mind, let's go ahead and look at our unit tests, right? Or let's look at the code for this. So I have my end-to-end tests up here, and then I've also got, just to start off with, I've got this code coverage report, which if I run my tests, just to make sure it's all up to date, good, or one more. So there we go. All right, so if I come back here, so you can see that the unit tests that I've written for this application, I currently have 100% code coverage in my unit tests. And that sounds really great, but it was actually a lot of work, even for this very simple application, to get to this point. So if we look at that, so let's just start with my data service. So here, this is my service that I'm using to go and retrieve data from the server. So I have my get data method. I have another piece of, or another function that I can use to go and get the data and format it into some other kind of string. I can go and get some other data based on that value. And then I can also send it back to the server and say, here is some new data to update. So to test this service, I went through and I had to configure Angular's test bed for a testing module. So I'm going through the process of setting up a whole, basically Angular module in order to test this. Providing the data service, going through and making sure that, if I go ahead and try and get the data and I subscribe to it, that I get back, what I put into it. And then, testing my math on, or testing that, I calculated the values based on the data correctly, while also retrieving it from the server. And then through here, because I've got multiple requests, right? I actually have to go through this process twice. I have to say I'm going to expect a request to this URL and then send back some data, and then I expect a request to a different URL and then get back some data. And then for my last unit test for this service, I'm going through and just checking that I have posted the data that I gave to it to the server, and then that it calculated the value that it should send back correctly. But let's actually look at our service here and think about what is this actually testing, right? So throughout this whole application, right, what could possibly make these things go wrong? So for get data, really the only thing that could potentially go wrong is if, in a unit test context at least, is if this URL is incorrect, right? But writing a unit test to make sure that a string is correct is kind of redundant, right? Because we could extract this to a variable. Let's see. Oh, this doesn't have that. So if we just copy that and say, something like const API URL, right? My unit test for this would basically just be expect that that URL is the right URL. So really, the test that I wrote to test this method is more testing the HTTP client service than anything else, right? It's testing to make sure that it did its job. And it's the Angular team's job generally to test that their code works. So we're going to go ahead and we can eliminate the test for this method. So if we come in here, we're going to say, well, I don't really need to test that it can get the data because that's mostly the HTTP client's job. So looking back a little bit more, again, we can extract this URL to this API URL. And then we have a little bit of logic right here, but this is just a function, right? So really what I want to test is that function. So if I do something like, const calculate derived data, and then set it equal to that function, then I can pass that function in here. And now the same kind of logic that we applied to get data also applies to this get data and format it, right? The unit test that we really want to write is just for this function. And that's much easier to do, right? So if we go into our unit tests, we're going to look in here, we're going to say, okay, well, we need to export that function so that we can test it, right? And that's fine, right? It's not going to have any kind of side effects if somebody else gets their hands on this. So we can go ahead and let me grab the function name. And instead of going through the process of doing the get data and format it, subscribing, and having to control the HTTP service, we can just say that we expect that the result of using this function with this test data is foo/bar. So we can now eliminate that. So we just simplified our test quite a bit. So the next method, again, we're not actually really using any of our own code to do any kind of calculations. We're asking the server for some data, and then just calling the server back with it. And the only calculations that we're doing, right, are based on this calculate derived data function, which we already have a unit test for. So we don't actually need to write another unit test for this method, right? So we can just eliminate a whole nother unit test here. And then finally, again, for this send back some data method, really, if we were wanting to be really zealous about our unit tests, the computation that we're doing here is with constructing this object. So we can do that in a method that we extract up to here. So we can use the same trick of calculate data for server. And we're going to say that we, are going to turn that. We pass in thing 1 and thing 2. So now we call that function here with thing 1 and thing 2. I'm going to drop it down onto 2 lines just for width's sake. So now in our spec, instead of testing this whole thing, including HTTP, we can actually just test this function that we created. So this calculate data for server, right? We can say we want to expect that the data here, so this is going to be the results of calling calculate for data for server with thing 1 and thing 2. And then we can eliminate most of the rest of this code here. Okay. I just need to import this. So now if we look back at our unit tests, really we're not actually using the actual service or the HTTP testing controller at all, which means that we really we can eliminate, right, the setup for that, right? Because we don't really want to test that Angular can construct our service, right? Like it knows how to call new on a class. So that's going to allow us to actually eliminate a whole nother swath of tests here. So we took a set of tests that started out as about 100 lines of testing code long, and we've gotten it down to less than 20 lines. And the idea, once again here, is that we're not looking to test to make sure that everything is working all together, right? That's what our end-to-end tests are for, right? And we're just looking to test that we're calculating things correctly. And more often than not, our calculations are very easy to extract into things like functions, which we can then test independently. So when you're looking at your code to think about your unit tests, take that time, be a little lazy, and think a little bit harder about potentially how you can refactor out some functions that you can then test, rather than trying to test the whole thing all at once. Right? So we're going to reduce the complexity of our unit tests by refactoring our actual code just a tiny amount, and then testing the refactored code. So another thing that it also can do is it then gives a name, right, to this calculation. So even if we weren't doing, looking at this from the perspective of testing, it is kind of nice to have, instead of a inline function that we don't necessarily, know exactly what it's doing, right? We have some description of what kind of calculation we're trying to make here. So our code becomes a little bit more self-documenting. So this is another advantage that we get just even outside the realm of testing with this kind of refactoring. So it's often very tempting to just keep everything in line. And very often that's how we you write it the first time. But again, the idea here is that we're being strategically lazy. We want to do a little bit of extra work up front so we can do much less work later. Okay, so that was a service with just doing HTTP. Let's take a look at another service that I wrote here. And this service is actually managing my state of my application. So for this service, I have an observable, which is the state of the data in my application. And then I have a method to update it, and then so I just have a method to go ahead and update it. So this is my state management system, like NGRX kind of light. And the big thing that makes testing this service really hard is this debounce time right here, right? Because this is actually going to force me to use Angular's async testing tools. Because if we look at the unit test here, so I'm creating a mock of my data service. I'm defining all the different things that it can do. And then I'm configuring my testing module to go ahead and create my service and mocking out the data service that with the mock we saw before. And then I'm going through and using the fake async API to take control of the clock in my test and say, okay, I'm going to go ahead and subscribe to the value of the data, right, the current state of my application. And I'm going to tick the clock, and I'm going to expect that it should be the initial value that I set in my data manager, right? So if we call, get data, right, which it's going to be doing, then we just get back that initial value. Then we're going to update, and we have to wait, again, 500 milliseconds in order to get past that debounce, in order to actually see the real current value. But again, let's think about what am I actually testing here. So the methods that I actually end up calling, right, this update, right, this is just calling next on a subject. And if we look at the code I have here, I'm not actually making any kind of really calculations, right? The thing that I'm mostly testing here is that my debounce time is working right? So this whole pipeline is really just a configuration. We can think about it. We can think of it as kind of a configuration of our RxJS code. And we don't want to test that RxJS implemented their debounce time properly, right? We just want to test code that we wrote, right? Code that we think might be breaking for us. So really, even though it's getting us extra coverage, right, this test isn't really testing all that much. So this would be another candidate for elimination, right? We're not actually doing very much calculation. This is all passing through to other things, mostly to RxJS. So we talked about two services. What about some components, right? So for example, I have here my app component, and I kept the spec that the Angular CLI creates by default. and expanded on it in order to make it pass. But then let's take a look at what the actual tests are doing, right? So I go through, I declare all the components that are being used by my app component. I'm importing some modules, including the HTTP client testing module, in order to stand this thing up. And then in my actual test, I go ahead and create the component, and I'm getting the component instance from it. And this is just basically making sure that it can get up and running, right? We know that it can do that from the fact that our end-to-end tests passed. And then we're testing that our title was set properly. But if we look at what that is, right, that's just, again, setting a property, right? Like if this line of code is broken, right, if that unit test fails for some reason, like we're in bigger trouble than, you know, worrying about the unit tests. So that's not really doing anything for us. And then finally, we have a test here where we're going ahead and checking to make sure that the H1 in our component has the text content set to be the right thing. But we actually already covered this exact scenario in our end-to-end tests, right? So we don't need to do it again. If we look in here, as part of the default end-to-end tests, right, it actually tests that exact thing, right? So it's kind of silly to test it in our unit tests if our end-to-end tests already do that. So really, there's not very much reason to unit test this component at all, right? So it's a whole nother file of unit tests that we can eliminate. So then we have our top level component for the actual application, right? And so in Angular, we generally implement approximately 2 different types of components. We have components like this one, which we call smart components, like cleverly named. And the idea of these components is that they connect our services and state management things to the components that we're using to construct the view, right? So this is basically entirely a pass-through, right? Our top-level component here is injecting the appropriate services to get data from, and then just using those services, right? And we already looked at this service, right, for unit testing, and we're already exercising all of this code in our end-to-end tests. So this class of unit tests that we have here, where we have to go through and we're mocking out that data manager service, right? And then going through the paces of saying, okay, well, you know, if we go through and look at, like, let's say we can actually grab a child component and trigger its event handler, and then make sure that our data manager has been updated, right? So what that's literally testing is that Angular properly handled this event binding, right? And if Angular doesn't, you know, handle this event binding, again, we've got bigger fish to fry if there's something broken here, right? We need to go and tell the Angular team, hey, there's something wrong. So again, there's not much to test here, so we can avoid it. And again, here we're saying, okay, if we get some new data in our mock, right, in our service, we're going to go ahead and say, okay, detect our changes and make sure that everything has been updated accordingly, right? So this is again, what is this testing? This is testing that these inputs worked, right? This is testing Angular. Our component here doesn't really have any functionality of its own besides telling Angular what to do, right? And Angular knows what to do. Angular has lots of tests of its own. So let's not test all that stuff again. So then finally we have two more small display components, one for displaying the data to the user, and then another one where the user can modify the data. And these are what we call display components. So the idea is that these components just have inputs and outputs, and they don't really care about the larger picture of the application. And generally, these components are going to be relatively simple, right? They're just taking in some data and then binding it onto the screen. And so our tests are going to reflect that, right? If we try and do some unit tests of this, what we're going to end up doing is we're going to go through and we're going to check to make sure that if we set the data to a new value, right, that it updated the right elements on the screen. But again, this is just testing that Angular worked under the hood. This isn't really testing our code, right? Our code is just telling Angular what to do, and so we don't really need to test. We can trust Angular that Angular understands how to do this binding. And then the same thing happens even if we have an output, right? So here we have an output from the form. And in here, in our tests, right, so we have a little bit of a more advanced way to do an input, where instead, if somebody sets this property, rather than setting a data property on this class, we're actually going to set the value on the form. So at first blush, you might think, oh, so here we have a function that is actually doing something, and so this is where we might arguably need some unit tests. But let's think about this a little bit harder, right? So all we're doing is calling set value on a form, right, inside this function. Forms are part of Angular. We're trusting that Angular has done a thorough job of unit testing. So really, we can rely on that, right? We don't actually need to unit test that bit either, right? So here in our unit test, we're going through and we're making sure that if we set a property on the component, that it updates the form value, right? And again, this is more testing that the form works than anything else. So we've gone through, and most of our components actually don't have all that much code that really deserves unit tests. And that's great, because components are generally much harder to test than just straight code. So what we're trying to do here, right, again, we're going through our code, we're looking for places where we can refactor in order to make our tests easier, and we're looking for places where if we really think about what we're testing, right, we're actually not testing anything that we've written, we're testing things that our library authors have written, right? And so if we do those things, then we can eliminate a whole swath of different kinds of tests. And the reason that we can do that, right, and feel good about it, is because we know, right, that we have our integration tests, right, our end-to-end tests, to test and make sure that everything works all together, right? So we're kind of tightly focusing on our unit tests on single units of code, and then we're testing the whole thing all together in an integration test with our end-to-end tests. So we've got two levels of resolution, and we don't really need to cover that in between, right? We can eliminate that by thinking a little bit harder. So that is my talk. So questions?
Okay, I've done a really effective job of convincing me I never need to test or unit test a component. When do I need to unit test a component?
Well, that's an excellent question. So you'll notice that what we end up with in our unit tests is really, like, after I get through, axe murdering everything, is a set of unit tests that focus on functions. So my argument would be that you actually generally wouldn't be unit testing services or components or really any Angular construct. You would be testing functions that you use in those things. Right, and that's a general rule. Again, there might be edge cases where you have to do something like that, but in the general case, functions are the way to go.
So I got a question. So any thoughts on how to deal with this problem like as your team scales? Because like I'm looking at all this and I'm seeing it from a perspective of like, yeah, I can make this work so long as the reviewer actually has the ability to control that quality, right? Any ideas on like how to scale this beyond small teams?
Yeah, so it's really going to come down to, I think, establishing a culture on your team of, if you're writing something complicated, looking for places that you can extract it out and isolate that complexity in a place that's easier to test. So yeah, I think it definitely is going to come down to, it's going to heavily rely on team leaders and reviewers of code saying, hey, this bit of code that you've written here, right, that's pretty complex. There should be a unit test around that. And so we should pull it out and refactor it so that we can make it testable. So there's a, like building a culture of writing testable code is a really hard problem. So that's why, things like this talk exist.
Yes, my question was, I've been on the other side of the fence as far as like making things public for the sake of testing. Is there any other way around that? I guess I'm just picturing me making something public and then my coworkers are going to go willy-nilly and start using that thing.
Yeah, well, so my answer to that would be consider what it is that you're making public, right? So generally in these examples that I'm writing, right, the functions that I'm exposing, right, they don't have any side effects, right? They're pure functions. They just take in some data, do some calculation, and return something. And so if somebody else wants to actually make use of this function in another part of the code, that's actually a good thing, right? Because it means that we're able to reuse code. So you would just need to be careful about not exposing functions that have side effects. I couldn't quite hear you.
I was going to say, if it ends up being useful, we should probably just put it into like a shared module.
Yeah, exactly. Yeah, and so what you might end up with is a kind of library of useful functions that you can use throughout your whole application, and that library is very heavily unit tested. And then you get you multiply the benefit of those unit tests because that code is then operating under the hood of all the rest of your application or applications.
Another approach that I've seen to this, and honestly I don't know how well it works with TypeScript because TypeScript kind of doesn't want you to do what I'm about to describe. But back in the more pure JavaScript days, what I would often do is use a technique that I'd seen other people do, which is essentially take what were nominally private properties or private methods and actually expose them via a sub-object that was named something like, fixture only for testing. So if you were using it for something other than testing, you knew that you were sinning. You knew that you were doing a bad thing. But the idea was that you were deliberately exposing these things only for their testing, and then they wouldn't be used otherwise. And I'd even gone so far in some cases as to have like a pre-production deployment filter that went through and actually peeled those things out of the code that would get deployed to production. So if you were literally using them for anything other than testing, it wouldn't work because the only reason these things were being exposed was for stuff like unit tests. Again, I don't know how well that works, or if there's even a version of that technique that could be made to work without real pain in TypeScript, but I've been interested in exploring it because I would like to be able to, I would often like to be able to get to things that should really be private, but still be able to, but for testing.
Yeah, tacking right onto what Bill just said, NX actually kind of can it be a big hammer to swing at this particular problem, but NX is a kind of a set of schematics that you build on top of the Angular CLI, but they come in the box with this idea of being able to like set up dependency management amongst your modules in your application and amongst your libraries. So you actually have we're starting to see tools emerge that say, like if we were to take some of this stuff that was like these pure functions that Jack's showing here and put them in their own little library, we could actually tell NX like only allow certain things to import these or deny importing these in certain locations. So at scale, solutions like NX work really well for the thing you're describing. So the audio is quiet because Jack's trying to cook something up over here.
Right, so I'm just thinking about how you would do it. Oh, I guess this would need to be protected, right? But you could do something like that, where you would have, you know, your class that you use in your actual code, and then in your you would write this class in your tests, but you would use this class for testing then, right? Because it would have all the same logic under the hood, just with more things exposed. So that's just my initial like 30-second.
I've played with something like this, and I still don't like the impact it has on my regular TypeScript code. I want my regular TypeScript code to be just like I would normally write it any day, and have the ability, still have the ability to like reach inside and test it. And those two goals can't coexist. I want my cake and I want to eat it too.
I mean, you do have different TS configs for your unit tests and your regular code, so you could turn off strict checking in your unit tests. That's one thing you could do. So.
All right. Any other questions? All right. Thank you, Jack.
All right. Thanks, guys.